Now we are going to solve Irodov's problem number 225 of the electrodynamics chapter. Here, this is a very long conductor having semicircular cross section. This conductor carries a current capital I. We take this current pointing out of the page. This is a cross section of the conductor. We have to find out the magnetic field produced by this conductor at an axial point, that is at a point on the axis of the conductor. Now the entire conductor makes an angle pi. So this elementary strip, we take an elementary strip within angle theta 2 theta plus d theta will correspond a current di is equal to I d theta by pi. Look at this figure carefully. This elementary strip will produce a magnetic field dB along this direction. This is dB is perpendicular to this length, which is r, radius of this cross section, and this dB must be equal to mu naught di by 2 pi r. We know it. This is the expression of magnetic field produced by a very long conducting wire, because this strip is now become a very long conducting wire. So the elementary magnetic field produced by this elementary portion of this conductor takes the form mu naught I d theta by 2 pi square r. Now look at the figure carefully. This half portion of this conductor will produce magnetic field along this direction, which is inclined along this direction. And what about the direction of magnetic field produced by this portion, the right hand portion? The direction would be along this direction. So the resultant field at O must be the sum of the component dB sin theta, because dB cos theta components cancels out. dB cos theta of this portion is upward and dB cos theta of this portion is downward. They cancel out. So the resultant magnetic field of this conductor at an axial point must be the summation of dB sin theta. So the integration is very simple, you know it, and the limit would be 0 to pi. This integration has the value of 2. So the resultant magnetic field at an axial point O will be of the form mu naught I by pi square r. Thank you.